Okay, so I was recently asked by one of my students to address a bit of the concept of sequences and series. And one of the questions I was sent in by a student was this one. This addresses AP, Arithmetic Progression. So let's just work through this and see if it helps make sense of the whole idea of arithmetic progressions and how we work with the sums and the terms and all of that. So let's read the question. The sum to n terms of a particular series is given by Sn equals 17n minus 3n squared. Now question A asks us to find an expression for the sum to n minus 1 terms. Alright, so for question A, we know that the sum to n terms is given 17n minus 3n squared. Now we want the sum to n minus 1 terms. Alright, so that luckily is pretty straightforward. All we do is we find the sum to n minus 1 terms. Now let me just write that a little slightly neater, n minus 1 terms. Alright, so all we do is instead of an n, we put an n minus 1. So we have 17 n minus 1 minus 3, and again instead of the n we put n minus 1 squared. And the rest of this is just now simplifying the expression, so let's continue to do that. We multiply the 17 in and we get 17n minus 17, and this one, n minus 1 squared, means n minus 1 times n minus 1. Just to remember that it doesn't mean n squared minus 1 squared. That is a common mistake that I see often. Okay, let's keep the 17n minus 17 minus 3 and let's multiply out this bracket. So n times n is n squared, n times negative 1 is negative n, negative 1 times n is another negative n, so we got minus 2n, and then negative 1 times negative 1 is positive 1. Alright, one more bracket to multiply out, and that is multiplying the 3 out, so negative 3n squared, then negative 3 times negative 2n is plus 6n, negative 3 times 1 is negative 3. And finally we just collect like terms, so negative 3n squared, that's the only squared term we have. Then we have all the n's, so 17n plus 6n gives us plus 23n, and negative 16 minus 3 gives us minus 20. So there is our answer to question A. Now let's look at question B. So question B asks us, find an expression for the nth term of the series. Okay, so for the nth term, we can use what we did in question A to solve this. Let's see why. Now before we get to actually answering the question, I'm going to do an example of something different. I'm going to say, let's say we had a sequence like 2, 3, 4, 5. Okay, so just bear with me as we do this example. So we can see that's term 1, term 2, term 3. Let's just write that down. So term 1, term 2, term 3, and term 4. Now if they ask us what is the sum of the first 3 terms, then we would say, well, that is just term 1 plus term 2 plus term 3, right? So 2 plus 3 plus 4, that gives us 5 plus 4 is 9. And what is the sum of the first 4 terms? Well, the sum of the first 4 terms would be the sum of the first 3 terms plus that 5. So 9 plus 5, 14. But term 4 is equal to 5, right? So the sum of the first 4 terms, equals the sum of the first 3 terms plus term 4, right? That gives us the 14 is equal to the 9 plus the 5. So you see, that makes sense. And this whole idea we can now use to solve question B. So I'm going to get rid of that, and we're going to start question B over with the actual answer. Okay, so let's do that. So what we just saw is that we can say the sum of the first n terms is equal to the sum of the terms before that, so n minus 1 terms plus the nth term, right? The sum before plus the nth term gives us a sum to n terms, and that makes complete sense. Alright, so all we do is we just plug this in and we can solve for Tn. Okay, so Sn, let's just get Tn by itself first. So we're going to say Sn, and we'll bring the Sn minus 1 over, so it becomes minus Sn minus 1 equals Tn. Alright, so let's plug this in because we have both of these here. We've got Sn and we've got Sn minus 1. So Sn is 17n minus 3n squared minus, and then Sn minus 1 is this part here, negative 3n squared plus 23n minus 20. And that equals our nth term, Tn. So let's continue working this out. This is just algebra from here. And now we can just substitute or distribute the minus in. So negative 3n is positive 3n squared. That becomes minus, that's an n, sorry, minus 23n and plus 20 equals Tn. So let's just collect our like terms. We've got negative 3n squared plus 3n squared, so those can cancel out. Let me just show we cancel them out. We've got 17n minus 23n, so that's negative 6n. And we've got plus 20. And that's it. There is our answer for question B. Negative 6n plus 20. And finally, we can have a look at question C. So question C says, show that the series is an arithmetic progression, an AP, and find the first term and the common difference. Alright, so for question C, what I think we'll do is the best idea is always just to write down a couple of terms. So let's just write down the first three terms. We already know the formula for Tn, so we can do term 1, and term 1 is negative 6 times 1 plus 20. That gives us negative 6 plus 20, which is 14. And we can do term 2, and I'm just going to do the first three terms. That's always useful. So term 2 would be negative 6 times 2 plus 20, which gives us negative 12 plus 20, which is 8. And term 3 will be negative 6 times 3 plus 20. And that gives us negative 18 plus 20, which is 2. Okay, so the question was, show that it's an AP, so we'll get to that, and find the first term and the common difference. So the first term we've already found. That's this one. Term 1 equals 14. So there is our first answer. That is term 1. Term 1. And now the common difference. The common difference is the difference between these. So let's see, what is 8 minus 14? That gives us, 8 minus 14, sorry. That gives us negative 6. So that's the difference. Is it common? Well, let's check. Is 2 minus 8 the difference between these two? What does that give us? Negative 6 as well. So yes, we have a common difference, and that common difference is negative 6. So that is our common difference. And to show that it is arithmetic, we just very much needed to show this. Let's just show it slightly more formally by showing that the difference is common. So to show that, we'll say if we're working with an AP, if it is an arithmetic progression, then we will have this be true. Term 3 minus term 2 will be equal to term 2 minus term 1. And we've actually already shown that, but let's just do it again. So term 3 is 2. So this part, we've got 2 minus 8, which gives us 2 minus 8, sorry, which gives us negative 6. And on this side, here we've got term 2, which is 8, minus term 1, which is 14. And that gives us negative 6. And since these two are equal, we've proven that it is an AP. So we've proven that, which makes it an AP, an arithmetic progression. I hope this video was helpful, and please let me know if there's anything else you'd like to know on arithmetic progressions, and I'll probably be doing a video on geometric progressions and quadratics in the near future as well.